Hi, my name is Jay and welcome back to my channel. And today we are going to talk about OpenAI Dev Day 2, in which they announced reinforcement fine tuning. And this is the method they used to train all the GPT O1 version based models. And they claim the O1 model is the best in the world according to the metrics. Let's try to look into what is reinforcement fine tuning itself. So uh, it's pretty simple. Reinforcement fine tuning is a process where model learns through feedback instead of directly being told what an answer is, like a regular supervised learning. Consider this an example where you have a model and you basically give it a prompt, classify disease, and according to the symptoms. And you basically give bunch of symptoms, and the model should output a single disease, which should be either cold, flu, or fever, or something. So in this case, the model basically gave three answers, which is like common cold, flu, and sinus infection. And what we do is that we do have a in a regular supervised learning, we basically tell the model it's flu. So whatever answer you told is wrong, go and correct yourself. That's what in a regular fine tuning or supervised fine tuning works. But in a reinforcement fine tuning, it's a bit different. What they do is that they basically take the input and the answers given by the model, and they ask a grader under an assumption that grader already knows the answer for this input to rank the GPT output score from 0 to 1. And then you basically feedback the score to the model. So instead of directly telling you did wrong and flu is the answer, you basically give it a score like zero point 0.3 is the score here. And then the model basically goes and sees that it did wrong, so it tries to improve itself. And they introduce this as a grader. A grader in this case can be a human like a doctor or another GPT model who is an expert in classifying the diseases or naming the diseases based on the symptoms. And the only difference is that in supervised fine tuning, you basically tell the model what the output answer is, and model will correct itself. In reinforcement fine tuning, you basically need to tell the model a score from 0 to 1, and you need to run the model until it actually finishes the or reaches a like a decent score for you. This is how fine tuning can be done on the portal. Once you go to the fine tuning thing, you can click on new, create, and you will see another option now, which is a reinforcement, basically saying the reinforcement fine tuning. And you can select any model whichever you want. After that, it's very similar to the previous ones. You need to select a JSON L file which is consisting all your inputs. And in this case, one input might be very similar to the previous one which we showed, where a 15-year-old woman has some symptoms, but they also doesn't have some symptoms. So that model should be very clear. And based on this, can you actually generate all the genes? And the instructions are nothing but prompt which we give to the, and the model basically generates an output which is the expected three genes for it, but the second one is actually the correct answer. We have shown before, what the model does is that it basically takes the answer, actual answer which we know, and the answers produced by the model, and it will basically give it to a grader, and the grader going to score it from 0 to 1. And this output score will be fed back to the model, not the actual answer, and the model needs to keep on improving based on this output score. And in this case, make sure that when you upload the validation data, make sure that the validation data answers doesn't match the training data. Otherwise, it doesn't make any sense and the model won't learn anything. So you basically need to upload your train JSON and test JSON or validation JSON, and you can select any kind of batch size and everything, but you can also leave it the existing one itself. And once you do that, the fine tuning job basically starts, and it will try with all this process finish, the job will be succeeded, the fine tuning, and it will basically show you as they shown in the demo. Initially the loss will be very less, sorry, the loss will be very high and the accuracy will be very less, but later on as it keeps on improving, you can actually see that it actually improved a lot. And this is the output results which they showed, and I just want to explain what each one of them is that. And the run basically shows the different kinds of model which they tested, which is the O1 alpha, O1 mini, and the last one is basically the fine-tuned one, the reinforcement fine-tuned O1 mini. And you can see that it does have highest scores when compared to the rest of the things. And what does top 1, top 5, top max mean is that top 1 is that the first answer given, as you can see previously the model gave 3 answers, so the actual answer should match the first answer. And the top 5 is that if the model gave 5 answers, like a list of 5 genes, the actual answer should present in the at least of one of the top 5. And reinforcement fine tuning gonna cost a lot because it gonna take couple of days to run, so make sure that you are running it on like a regular model instead of a really big model.